Hello, welcome back. Okay, so in the last video, we were discussing part A of question 5 in investigation 6, module 5. And we were asked the question, what does the quantity theta over 2 represent in the definition? H of theta is 12.5 times the cosine evaluated at the argument theta over 2, and we said that this is the measure of the angle swept out counterclockwise from the 3 o'clock position. Okay, so part B asks an important question. It says, what interval of the quantity theta over 2? Ooh, am I missing something here? Did I skip 5A? All right, now we're on to 5B. What interval of the quantity theta over 2 results in one full cycle of output values for the function h? Well, the function h is sine of theta, or excuse me, cosine of theta, and the cosine function takes 2 pi to complete a full cycle of outputs. Now, the argument to our function, the argument to h, which is a cosine function, theta over 2 is the argument of h, and if we set our argument theta over 2 equal to our period 2 pi, and then multiply both sides of this by 2, we get theta is equal to, the interval for the completion of one full cycle is 4 pi. And I believe I've done it again. If I'm not mistaken, I've answered this is part B and part C. Part C asks us to define the interval theta over which a complete cycle is made. A more traditional way to approach something like part C is if we have, in general, if we have a h of theta equals some number a times the sine or the cosine, and we have some numeric multiplier of the angle theta in our argument, we could use the formula period, sometimes denoted t, will be given by 2 pi over b. Nice formula. And in our case, h of theta equals, what was it, 12.5 cosine of 1/2 theta, or theta over 2. And using our formula, using this formula, we would conclude that our period is 2 pi over 1/2, which gives us 2 pi times 2, precisely the same result we got before. And so our period, the time it takes for one complete cycle of outputs, would be 4 pi. Okay, so I've drawn for you here in black the function h of theta equals 12.5 cosine of theta, which will have period 2 pi, which we could see here, makes it a little clearer, right, that our interval where from peak to peak, that is, we start at our minimum and we return to our minimum after, do I have this right? Pi, 2 pi, over 2 pi radians. And what I'm going to draw for you now is h of theta equals 12.5 cosine of theta over 2, or 1/2 theta. So note, we're going to take all of the same input variable theta, and we enter them, and in each time we're halving them. So what that means is it's going to take twice as long for this function in blue to complete a full cycle. So let's draw that. So now we will have completed a half of a cycle. We would have a half of a cycle after 2 pi, and we would complete a full cycle of outputs after 4 pi in this manner. It in effect stretches the period of the cosine by virtue of this halving the input values. Key here is that the period for this function is 4 pi, because 4 pi corresponds to the amount of time it takes to return from our to our starting value, which in the case of this function is here at 12.5. And I suppose part E of this question is just reinforcing the notion that because we're dealing with h of theta equals 12.5 times the cosine of theta over 2, this is the so our output is the horizontal distance of horizontal distance to the right of the vertical diameter, the vertical center of the wheel, vertical center of the wheel's tire valve, I should say, tire valve measured in inches, because we've multiplied by this factor of 12.5 inches, our radius length. I'll see you in the next video.